Hi, I'm Larry, W6WUH, and as I've done before, I want to introduce you to another quite rare AM mobile transmitter. On the left, we've got the Mars Thunderbird mobile transmitter, circa about 1960. It's a 3-tube transmitter, a 6 AQ5 Heising modulated by a 6 AQ5 using a carbon microphone with a, I believe, a 12 AU7 crystal oscillator and driver. This is quite rare. There's probably around 100 examples made, and I know about 8 or 10 of them around the United States that I hear about anyway. First one that anybody I knew had, W6WUH, my old friend Greg. I think he's had one for more than 30 years. I've had mine for about 20. And Bob Heil got his last year, 2018. I sent him a schematic and a parts list for it. Recently, a ham in California sent me this. This is in Mars MT-75A. And if this is rare, or extremely rare, this one is virtually unknown. I've been been around ham radio for 60 years, and I had never heard of this model, the A model, MT-75A. Never heard of it. Looking through the literature, I can find one reproduction of an ad. At really no mention of it otherwise. Extremely obscure. And what it turns out to be is a repackaging of this transmitter. So let's compare them for form factor and size. You can see that it's just about the same width. Maybe it's an inch deeper. That way, 3/4 of an inch deeper. And quite a bit less tall. So let's open it up and take a look here. You'll have to excuse me, I'm quite ill. Not really playing with a whole deck. I'm going to stop the camera for a minute, and I'm going to let it run. You go ahead and watch me do this. Won't kill you. Oh, let's see. So we're going to take a look primarily at the MT-75A because as far as I know, nobody's ever seen a damn thing. But I haven't got any documentation on the 75A. I've got schematic and parts list for this one, of course, but I want to, as far as I can tell, this is basically a repackaging of this transmitter with a couple of changes. And we can look at the front panel here right away and see the most major of those changes is that they have added an oscillator tuning capacitor. This has a slug-tuned oscillator coil, and you just tune it in the range and pray for the best drive you can get. This lets you optimize your drive, which in an AM transmitter of any kind is absolutely essential. You cannot modulate an AM transmitter well if you cannot saturate the grids of the final tube. If you don't have enough drive or excess drive, you can't saturate the grids which means you run the grid drive up until the output of the amplifier doesn't go up any farther, and then stop. And that's the ideal way to operate an AM transmitter. If you can't get that much RF drive, you're not going to ever be able to modulate it well. So here we see one of the main mechanical differences. This is built on a copper-plated chassis, but with all of the guts exposed underneath. So there's the choke used for the Heising modulation, and here it is here in this transmitter. So you can see that all of these components, if you want to recap the thing, which you'll want to, are available here. Here's the bottom of the band switch. The only thing that's kind of hard to get to seemed like there was something that was really tough to get to, and I guess it's just these components here on the band switch. So there's the layout there with a straight little U-shaped chassis with a panel on the front of it, and it gets a lot of rigidity from the case, but it's a good rigid setup anyway. It's two 6AQ5s, the final in the modulator, and a 12AU7 for the oscillator driver. So here we've got the MT-75A. This is the repackaged version. So you can see what the main differences are. They've got a cheaper kind of a crystal socket, a little bit different mic jack, although the same mic will work. Different meter. Now this meter looks kind of cute, and maybe this this kind of plastic stuff on the thing looks cute, but if you're looking at it from an angle, you can't read the meter anymore. This one you can read when you're looking down at the meter, but this business here, whatever you call this, makes it difficult to read that meter, so I'm not real fond of that. They've gotten rid of this beautiful machined glass jewel, and they traded it for a little glued-in plastic thing. So that's a cost-cutting measure. No big deal, really. The real change is in the chassis, where we see we now have two different parts. We've got this end skirt. We've got these long screws with the standoffs in between, and we've got the main chassis here horizontal. The good news about this is that 6AQ5s get exceedingly hot. The bulb temperature gets up around 400 degrees. You can burn the living piss out of your fingers on a hot 6AQ5. So maybe the cooling is better this way. You can see that there's vents on the bottom and vents on the top, so that there's a path right up past the tubes, and the cooled air can come in the bottom and the hot air can escape up the top. And that may keep the other components cooler. I don't know. When I get around to making up a power cable for this, if that one doesn't just plug and play with it, we'll run it, we'll put an infrared thermometer on it, and we'll see what it does. But let's take a look here. I don't know the answer to this. I'm going to take a look and see what this oscillator driver tube is. You notice they've retained these nice little spring clips, so these things were really made to be able to bounce around like mad in a mobile situation and not take any gas. This is a 12BY7. Okay, classic oscillator driver tube with a lot of power capability. So that's a change from the original Thunderbird, which uses a 12AU7, just as a twin triode. And 12AU7 is still capable of a few watts per section. Ought to be more than enough. but they've gone to a 12BY7. Uh-oh, the meter face just came off of this. That does not make me happy. So I better be a little more careful. As I said, I'm not feeling well. So I'm going to put this back in here. So there's two changes in the circuit from the classic Mars Thunderbird, and that's a change from a 12AU7 oscillator driver tube to going to do this later when I'm not busy talking, because it's not all that easy, and I'm not really playing with a full deck right now anyway. So anyway, let's just go ahead and take a look and compare layout here and components and see what we find. So there's the band switch in the classic with the little oscillator coils there for 80 and 75 or 40. By the way, this is a 2-band transmitter for 80 and 75 meters. So here's the band switch here, and where have they moved those? They've moved those little coils. Beep-a-dee-ba-dee. Up here, it looks like. I don't know. We'll have to figure it out. Here we go. There they are. So, what else can we see? Here's the 40 and the 80 meter oscillator coils, L1 and L2, and here they are over here. But now they're in a nice little, their own little shielded compartment. They're on little L brackets now instead of being held in by these screws at the top. So it's a cheaper coil. They were slug tuned coil forms, and they're no longer slug tuned. They're fixed tuned, but we've got the oscillator tuning capacitor instead, which for my money is a excuse me, a better setup. So here's the tank coil here. Let's take a look at the tank coil over in the other one. Here's the tank coil in the classic Thunderbird transmitter. Phenolic core, about 5/8 of an inch diameter. And here's the tank coil in this one, which is a piece of mini-ductor about 3/4 of an inch in diameter, 7/8, and a much more robust coil, probably with a lot more inductance. So our LC ratio is probably going to have changed there, and probably for the better. I saw somewhere that someone had one of these MT-75As, and he'd made a little chart of power output on 75 and 40 meters, and he was, you know, showing about 3.8 watts out on 80 and a little less on 40, and that's just about what this thing was doing. So theory is one thing and practice is another. Apparently you just are only going to get so far with this kind of thing no matter what you do. And the limitations of a 6AQ5 are such that, you know, somewhere between 3 and slightly under 4 watts output, carrier output, is as much as you're going to do. And as with all of these little transmitters, it's far more important to load it up in such a way that you can get 100% modulation or close to it, rather than worry about the maximum carrier output unmodulated. It's not unusual to see these things where you can crank up the unmodulated output up to 5 watts or so, but when you modulate it, it just folds over and it goes negative. So it's far more important to heavily load it and get it to modulate to its highest capability. This is Heising modulated, so you've got a carbon mic taking some current through the cathode of the tube, and then you're impedance matching it to the grid with a little transformer, and then the modulation transformer in these things is really a choke. And what they did in this one, at least, is they took a little output transformer and they shorted I can't remember if it's the primary or the secondary. I think and they use one side of it in series with the B+ line as a modulation choke. Just a cheap and dirty way to get a modulation choke using a little output transformer, and I'm pretty sure that that's what they've done here, but we'll have to take a look and see how many terminals are on that thing to figure it out. But anyway, there we go. It's all pretty straightforward. All the components you'd find in any transmitter are there. There's the RF choke, there's the plate blocking capacitor, so I don't know, there we go. This won't have very much to do. It's got there's one little oil-filled electrolytic, there's another one, there's two, here's a little tubular electrolytic, so there's 3 capacitors. I think that's about what it took in this one. See that I've recapped this one, and there's 2 new electrolytics there. And then I think, where in the mic circuit, there's another one. You can see I replaced another capacitor, paper capacitor down there. So it looks like this one's gotten 3 new capacitors as far as I can see. It's been a long time since I did it. So there we have it. The Mars MT-75A mobile transmitter. This will use 300 volts of B+. It's got a switch on the back where you can select between 6 or 12 volt filaments. On this one, you had to there's either a jumper on the pin or you select a different pin on here. I can't remember which, but one way or the other, it's selected on the plug. But on this one, they added a filament switch, which is kind of nice, but it's also kind of dangerous, because if you're running the thing on 12 volts and somebody flips that over to 6, you know what's going to happen. You're going to smokify some expensive tubes. So anyway, all in all, I think it's a really nice form factor. In terms of, you know, the thing back in the day was, you know, the wife didn't really want you to be putting your radios under the dashboard of the car, and nobody really wanted to be in there knocking their knees on them if they were. Cars used to have metal dashboards, and you'd put screws in the bottom of the dashboard and put the little mobile bail in there and hang it under there. So, you know, this one was just that much shorter, you know, almost half the height, which is you know, kind of nice, and should work pretty well. So W6WUH Inside Classic Ham Radios. There's a quick comparison of the Mars Thunderbird MT-75 and A.